class and fail, but work hard, eventually pass. That working hard is what probably is missing. So education generally is a thing. Yearning for knowledge, being hungry for wanting to know, which you don't know. You.
So how do we identify who we know? So these are the ones who should be taken to school. The rest of us idiots are supposed to go and become carpenters and everything else.
No,
but how do we identify? Because if for me and you in class having the same thing, I'm holding you back.
Kibe, not everybody can be a doctor. Not everybody can be.
But that point of mine, I have a good point.
Okay. Yeah, it is a good point. I'm coming there. Not everybody can be Babu. But people are talented differently. You can't get the best.
Dear physics students, I know we've come a long way, and it's almost now time for you to sit for your Igcse Edexcel physics. I want to take this opportunity to read for you the letter that I've dedicated. This is a letter I've sat for more than 3 days to write it for you, so that it can maybe give you confidence, so that you can be able to face your exam with that confidence that can enable you to pass. Let's go straight into the letter, and I would like you to pay close attention to every detail that I'm going to include in this letter, and take this letter as if your life depends on it.
From teams. These papers you can get from anywhere. They are everywhere.
Dear physics candidates, as your Igcse physics exams are quickly approaching, I want to take a moment to remind you of the hard work you have put in so far, and encourage you to stay focused in the remaining 2 weeks. You have already come a long way in your studies, and you should be proud of all that you have accomplished. Remember, the hours of practice, the late night of study sessions, and the moments of frustrations when you were stuck on particular concepts. You have persevered through all of these challenges, and you are now in a position to excel.
I'm not restricting education purely.
With just 2 weeks remaining before your exams, it's important that you make the most of this time. And in this particular letter, I've given some tips to help you carry out your revision effectively. Number 1, create a study schedule. Plan out your remaining days to ensure that you cover all the materials you need to revise, and remember to divide your time between different topics and set realistic goals for each and every day. Review your notes. Remember, I've given you all the notes that you needed after energy resources and energy transfer, solids, liquids and gases, magnetism, electromagnetism, radioactivity, particles, and astrophysics. Remember, astrophysics was having the concept of part of stars, how the moon goes around the earth, how the earth goes around the sun, and how the comet goes around the sun. You remember those orbits and how beautiful they used to appear, and I believe as we are going to continue with this letter, you are going to see the significance of what we study. I would like to remind you on the forces and motion, we learned about average speed. You remember that early morning when we started the specification, I came and I told you that average speed equals to distance moved divided by the time taken. And there is a question here whereby you are told a speed camera is positioned at the side of the road. So meaning that if you know the distance covered and the time taken, you can be able to work out the speed. And now average speed, of course, if you are told to work out that speed in meter per second, if initially distance that was given was in kilometers, and time that was given was in seconds, then it means you have to convert the distance that is in kilometers. Remember, 1 kilometer equals to 1,000 meters. Now, for instance, if you have 6.5 kilometers, it means that you can be able to multiply by 1,000. I'm talking of this because there are some situations whereby you may be expected to work out speed in kilometers per hour, or you may be asked to work out speed in meter per second. But now back to this specific question. You are able to note that during our discussion and our revision, this distance was 6.5 meters between when the two pictures were taken. The car covered 6.5 meters, and the time elapsing for two pictures to be taken was 0.25. So if you divide those two, you are going to get the speed to be 26 meters per second. Now the third part of the question, we were supposed to check whether the car exceeded the speed limit. The speed limit was 80 km per hour. So we cannot be able to compare 80 km per hour and 26 meters per second. We had to change 80 km per hour and see what is it in meter per second. So remember, 80 kilometers can be converted to meters, and we shall do that by multiplying by 1,000. And 1 hour is equivalent to 3,600 seconds. That's why you see I was able to divide 80,000 divided by 3,600, and that gave us 22.2 meter per second. And you can now see this speed at which the car was moving did exceed the speed limit. Another interesting area that we did look at is whereby we discussed motion graphs. Remember, we divided the motion graphs during our discussion as distance time graphs or displacement time graphs. And we say that when you have a straight line like P here, this means that the gradient is constant along this line. So meaning this car was moving at a constant speed. But if you have a distance time graph whereby you have a straight line horizontal like that, it means that this object is not moving, this object is stationary. Velocity time graph, you can be able to get from a velocity time graph, you can be able to get acceleration. Now, since the gradient is constant, it means this object is moving at a constant acceleration, but this one is moving at a non-uniform acceleration. And in this case, this object is accelerating because the gradient from each and every point is increasing. All those ideas I've identified there must be fresh in your mind so that as you are going to face your exam, remember, we discussed all this. Go through, and if it's not clear within you, you need to check. Another area that we talked is whereby you are given a distance time graph like this. So these are different regions. And you need to note that there is these flat regions, B, D, and F. This is where the object is stationary. The bus is stationary. B, D, F. The bus is stationary. And if you look at this, the steepness of A and the steepness of G, G is more steep. This one is not steep. Or we can even compare E and G. Yes, this is increasing, but G is steeper than E. So meaning at E, this bus is moving at a velocity, a lower velocity. But here, it's moving fast. So from distance time graphs, the gradient represents the speed at which the object is moving. We are supposed to work out the speed during C. Speed during C. you need to check what's the value at this point.
Mm.
So you need to check the height of this line, rise over run. Of
Imagine
course, it's going to
thinking,
give us the gradient. So you can be able to work out the gradient of C. And remember to understand the scale. So the rise here is 2.6. You have to check and actually read this mark. And you need to check across here what's the reading at this point. What's the reading at this point. And also you check the reading at this point. Then you find the difference between the two. Yeah. So if you find the difference, you're going to get 2.6. And also for you to take the time taken, you must check this value here and also this value here. You subtract and you're going to get a difference of 2 because this is 5 and this is 7. So 7 minus 5 is going to give us 2. So those are the concepts that we looked at, and we were able to realize that the speed was 21.67 meters. Don't forget the units for speed is meter per second. Now, after looking at that, we also went ahead to talk about acceleration. And we said acceleration is the rate of change of velocity, which can be given by this beautiful equation here, v minus u over t, where v is the final velocity, u is the initial velocity. Now, we have a question to remind you in this letter. I've written that a car accelerates from rest. What did we say at rest mean in physics? At rest means the velocity is 0 and it attains a velocity of 25 meters per second. So this becomes the final velocity. This is the initial velocity. How long does it take? Is 2.6 seconds. Now, having remembering that, having discussed that in class, it doesn't mean that you have to forget. Yeah. So that now you can be able to apply the formula. And I said, let me just repeat. When you are given a question like this, identify what you are given. We were given initial velocity 0 meter per second. Final velocity 25 meter per second. Time taken 2.6. Then you can now be able to put that into the formula in order to get your answer. Dear physics candidates, I believe you are following exactly what we did. Now, we can move to the next part. Remember that fateful morning when I came to class and I started teaching you about velocity time graphs. I told you for a velocity time graph, this means that velocity is on the y-axis and time is on the x-axis. Remember in your notes I wrote and told you that for a velocity time graph, the area under the graph represents the distance covered. And we say that even if you have whichever shape, you are going to subdivide that region of the area under the graph into geometric shapes that you know. You can subdivide into a triangle, a rectangle, and then you work out the area of each of them in order to get what? To get the area of that graph. And the area that you get is not going to represent the distance moved by the object. Remember that that day when I gave you the exercise, and when I tried to test you on the same concept, one of you did this. Most of you, let me just be very categorical, most of you made this mistake when they were told to work out the distance covered by the object from the graph. What did you do? Do you remember what you did? You went ahead and checked the velocity and you checked the time, and you decided to use the formula distance equals to velocity times time, which is wrong. When you are given a graph, when you are going to do your exam and you are given a graph, for you to work out the distance covered by the object, remember that it's the area under the graph. Yes? Now, in this region that we have here, I need to also remind you, in this region that we have here, we have a linear line, a straight line. This has a positive gradient, meaning this is a uniform acceleration. It's uniform because this is a straight line. And since it has a positive gradient, it means its acceleration. At this particular point, the line is straight. Yeah, you can see now it's across 40, a straight line across for 5 seconds. The velocity remained the same, meaning the object was not accelerating, did not accelerate during that time. Therefore, it was moving at a constant speed, which is 40 meters per second. And then when it reached here, after 10 seconds, the speed started decreasing uniformly. So meaning this car was decelerating. Now deceleration, it means if you work out the gradient here, the gradient should be a negative gradient. So I believe now that one we are done. Let me now remind you on this concept that we did in class. Velocity time graph shows how the motion of the lorry changed. I think you remember how we discussed this. Explain how the graph shows that the lorry has a constant acceleration. Now, since this is a velocity time graph, from the gradient we can be able to work to get what? Acceleration. And I want you to remember that if this is a straight line, it means that this is a uniform acceleration, and this is a constant acceleration because the gradient along this line is constant. Yes, so that now let's also look at the formula linking acceleration, change in velocity and time, and also we shall look at calculate the acceleration of the lorry. And remember here we said you will work out the gradient of the line, and this is exactly what we discussed. And we said this is a constant acceleration because it is a straight line and it has a constant gradient. The formula linking acceleration, change in velocity and time, we say this is acceleration equal to change in velocity over the time taken. And for you to work out the acceleration here, we shall find the gradient of the line, which is rise over run. And we got the answer as shown there. The second part to remind you is this particular question, whereby we were supposed to calculate the distance traveled by the car during the first 0.4 seconds. During the first 0.4 seconds. Look at this. We have 0 here. We have 0 there. We have 0 there. I think something has happened here. Let me just... Now, in order to work out the distance traveled, we have already said we are going to work out the area under the graph. And we are going to work it up to this particular point. So, which means that for us to work it out, we shall find the area of a trapezium. There are different ways you can be able to work out this. However, you can be able to subdivide this into a triangle and a rectangle. And remember, we have our 0.4 seconds at this point. So you can be able to work out area A and also area B. Now, once you do that, you will get the answer. However, you can be able to just generally work out the area of a trapezium and you'll just get the answer. Remember, area of a trapezium is a half AB, a half H into A plus B. And if you substitute that, you are going to get our area as 1.29 meters. Remember, distance from a velocity time graph is the area under the graph. And acceleration is also the gradient. And if you work out the gradient of this line, you see this is sloping to the left. It means the gradient is going to be negative. So this car or this lorry at this particular point was decelerating at that particular rate. Point to remember, point to note is that whenever you are doing this question, remember to check the scale that is used. I told you, you have to know what does one small square represent so that you can be able to make the readings from the graph. I want us to change the gear and look at equations of motion. These are the equations of motion that we talked about. One of the equations of motion is this: v equals to u plus at. Where v is the final velocity, u is the initial velocity, a is acceleration, and t is the time taken. The second equation we talked about is s equals to ut plus a half at squared. And I mentioned this. This one you have to be very careful with it because it's very, very common in Igcse Edexcel exams. This is the question most of the time examiners test and check whether you know how to use. Whereby v is the final velocity, u is the initial velocity, a is acceleration, and s is displacement. Do you remember this in your notes? When I told you a plane accelerates along a runway from rest, and I told you from rest it means the initial velocity is 0 at a rate of 18 meters per second square. So in this question we are given acceleration and we are told that it covered a distance of 46 meters. So at what speed did this plane take off from the runway? And we said now, if you check in this question, we are supposed to work out the final velocity. So we are going to use this equation because we have final velocity, which is the one that we are finding. We have initial velocity, which is 0 because we were told it accelerated from rest. Rest in physics means 0 meters per second. We have acceleration 18 and we have the displacement, which is 46, so that we can be able to put this into this formula, and our final velocity is going to be 40.7 meters per second. So as you are preparing for your exam, as you are revising, as the days are fast approaching for your exam, remember how to use this formula. Differences between vector and scalar quantity. You remember this when I came there and I said that a vector quantity are those quantities which are described by both size and direction. And I also said that size is the same as magnitude. So if you can also define a vector quantity as a quantity that has got magnitude and direction, you are good to go. You'll earn your marks. What about scalar quantities? Scalar quantities can be described by only size. They lack direction. An example of a scalar quantity is time. An example of scalar quantity is distance. An example of scalar quantity is volume. An example of scalar quantity is speed. An example of scalar quantity is mass. An example of scalar quantity is area. All those that we mentioned during our lessons should be fresh in our mind. Also, we also talked about vector quantities. We talked of displacement being a vector quantity because displacement has got size and also direction. I told you, one of you in that day when we were having a lesson, stand up, move 5 millimeters to the left. And that friend of ours and that guy of ours moved 5 meters. But I had told him to move 5 millimeters. You see now, since displacement has got size and also the direction in which it's oriented, it means that's a vector quantity. Velocity is a vector quantity because if I say run, if I tell you run, in which direction do you want I want you to run to? So if I tell you run to the east, so meaning I'm defining the direction. So if I just tell you run 5 meters per second to the east, so that becomes velocity. But just running 5 meters per second without specifying the direction, that becomes speed. Acceleration is a rate of change of velocity. So acceleration is a vector quantity, force is a vector quantity, momentum is a vector quantity, moment of a force is a vector quantity. All those that we mentioned should be with you. Do you remember force and shape? when I came with a rubber band and I stretched it, meaning force can stretch materials, can change the size of objects. Remember also that day I came with a balloon. I compressed it. So force can change the shape, can change the size, can change the speed, can change the direction of an object. So those are effects of forces. And we defined force as a push or a pull on an object. Force is a vector quantity because it has got both size and direction. Weight is a vector quantity. And we also discussed different types of forces. We talked of friction force, a force that opposes motion, a force that stops object. Yeah. Like now, for instance, we have this beautiful saloon car here that is moving from town X to town Y. Between the wheels of this car and the road, there is friction. As the car is moving, if you put your hand outside this car, you'll feel some forces pushing you back. That is air resistance. We have upthrust force. If you drop an object in a fluid or in a liquid, you experience upthrust force. Now, for instance, if you are swimming in a swimming pool, you feel you are light. You feel you are light because there is what? Upthrust force. There is an upward force that is pushing you up. And this type of upward force that we are talking about is called the upthrust force. Yes. Now, friction actually is caused due to the interlocking surface. You see now, when the surfaces are rough and there's an object and those two surfaces are in contact, they will interlock each other. And we also decided to discuss in our lessons ways to reduce frictions. We said smoothing those surfaces using balls and bearing. And you remember this part of experiment that we did in our lab. We placed a heavy box on rollers, and it was very easy for you to pull that box, and that reduces friction. Another way we reduced friction during our practicals is using what? Oil and grease. And you realize that when now oil and grease is applied, it covers these regions which are interlocking there. So in that way, those surfaces can be able to slide easily along that surface. Another part that we also talked about is resultant force. When two forces are acting on an object like this, we have a force acting of 20 Newton acting in this direction, and there's another force acting in this direction. This is 12 Newtons. I took you out that morning when it was raining, and I gave you a rope. There were some people pulling this side, and this other team was pulling here. And you remember, those students who were strong had to win the tussle. Yeah. Now we have a resultant force. How do we get a resultant force? A resultant force is a type of force whose effect is equivalent to all the available forces. Now, for instance, we have 20 Newton and 12 Newton. Now, which force can we represent or can we replace with these two forces? First, the resultant force will be, because these two forces are acting in opposite direction, it will mean that we're going to subtract the two forces. But if the forces were acting the same direction, it will mean that we are going to add the forces. So the resultant force in this case is 8 Newtons by subtracting the two. So which means this object is going to accelerate towards the greater force at a force of 8 Newtons. And remember, this is the force that is going to cause the acceleration. There is another scenario here. We have a ball. A ball is acting upon by 4 Newtons, and another force is 4 Newtons. And now we have a scenario here we call the forces are balanced. Balanced forces. So when the forces are balanced like this, it means there is no resultant force. So the object will remain undisturbed. It will remain like that. I believe we are okay up to that point. Now let us look at this question whereby we are told that the diagram shows a van accelerating along a horizontal road. The horizontal forces acting on the van are force X acting in that direction. We can see it's acting backward, and there is a driving force of 2500 newtons. Now we are supposed to name the opposing force. This force, we call it air resistance. As the car moves, drag or air resistance, try to slow down the car because it's acting in the opposite direction. And as the speed of the car increases, by the way, I want you to remember that as the speed of the car increases, air resistance also, the force, the magnitude of air resistance increases. So if a car is moving slowly like that, the air resistance will be less. But if the speed of the car increases, air resistance also is going to increase. We're going to look at that later when we shall be talking about terminal velocity in this letter. This is your letter. Remember, I told you that you have to look at this letter as if your life depends on it. Now we have a driving force of 25 Newton and there is air resistance. But we are told that the resultant force is 1500 newtons, 1500 newtons. Then we are supposed to find X. But how do we find resultant force? Resultant force equals to the difference of the two forces. So our second force is X. So if we rearrange this, we are going to get our force X is 1000 newtons. You remember Robert Hooke? When I came with springs in class, we added some masses so that we can see by how far the string stretched. One of you added an extra mass and our spring was deformed. I was so disappointed. But I want to take this opportunity to remind you that extension equals to the new length. Remember, before you add a mass on the spring, when we did this experiment, we noted that there was a pointer reading before we added some mass. And when we added some mass, the spring stretched, and in that way we were able to get a new length. And in order to get extension, you subtract the two. So if the original length was maybe, let's say 5, and when you add the mass it becomes 10, for you to know by how much as the spring stretched, you subtract 10 and 5 and we shall get the extension. If that is well understood, I want to remind you how Hooke's law states. Extension is directly proportional to the force applied, provided a last limit is not exceeded. We went ahead after doing those experiments. We were able to get tables, force and extension, and then we plotted a graph of force against extension. We were able to get a straight line. You remember when we were discussing this, we said the region that is very straight here, it indicates that force is directly proportional to extension. In this region, you have a straight line, which means force is directly proportional to extension. Up to the last limit, it was a straight line. And when we have a straight line, it means that this object obeys Hooke's law. So I said that you during exams you will be given graphs. If the graph given is a straight line, it means the material used to come up with that data obeys Hooke's law. So this can be a spring, this can be a wire, which gives you a straight line. So the material obeys Hooke's law. But now a scenario whereby you do a practical and then plot extension against force or force against extension, and you get a shape like this, a curve. you are not having a straight line. So means that this material does not obey Hooke's law. That's what we said. Yeah? You should remember this before you sit for your exam. And now you look at this question now. Look at it. Explain how the graph shows that the rubber band does not obey Hooke's law. Explain. Just look at the nature of this graph. It's not a straight line. It's a curve, which indicates this is not a straight. This is what you are supposed to say. And by the way, the graph is not a straight line, indicating that extension is not directly proportional to the force. So this does not obey Hooke's law. But where you have a straight line, it means extension is directly proportional to force. So it obeys Hooke's law. Now this region of elastic limit, this is a point where the material, if you continue adding the force, you reach a point where when you add the force now, the material the extension is not proportional. Yeah. When you add the force, you are not going to have a straight line now in this case, meaning that in this particular region where we have a curve here, the material does not obey Hooke's law. The extension is not directly proportional to the force applied. And that limit is what we call the elastic limit. This is the maximum point at which this particular material obeys Hooke's law. Are we together? I believe you are getting along well, and you are remembering a lot of concepts that we discussed during our lessons. This letter was meant to assist you revise. This is not all that you ought to know, but I wanted to take you through exactly what we did in class, exactly what we mentioned, key areas that you must remember when you are going into exam. Forces and movement. Remember we said in class that force can make an object to move. Yeah. And one of the concepts that I emphasized during our discussion for forces and movement is the relationship between force, mass, and acceleration. And let me tell you for free, you are going to see these kind of questions that state the relationship or write an equation linking force, mass, and acceleration. And when you are asked that question, this is what you are going to say. Force equals to mass times acceleration. Write your answer in full. And then if you want to write in simples, you can be able to do it. And remember, the force that we are talking about that is making object to accelerate is the resultant force. Unbalanced force. If there is no unbalanced force, there is no acceleration. If the forces are balanced, an object is going to continue moving at a constant speed. This is very important. Remember, I told you, look at this as if your life depends on it. Let us look at this question that we are given here. This is one of the Igcse Edexcel question. State the formula linking resultant force, mass, and acceleration. This is exactly what you are going to write. A mass of the van is 1,900 kg, and then you are supposed to calculate the acceleration of the van when it brakes, and the resultant braking force is 14,000 newtons. 14k newtons. K in physics means 1,000. So 14 times 1,000 gives you what? 14,000 newtons. So that we are going now to work out this. Force equals to mass times acceleration. And since the force is 14,000, the mass is 1900 times A, then we substitute. Remember, this is decelerating. This is the braking force. That's why I've identified this as a deceleration, negative 7.37 meter per second square. Remember, the units for acceleration is meter per second square. Next question was, the fan was traveling at the initial speed of 18 meter per second before braking and coming to rest. So meaning the final velocity is 0 because it came to rest. The final velocity after the force had applied, the car will slow down until it comes to a complete stop. Initial velocity was 18 meter per second. It came to rest. So V, final velocity, is 0 meter per second. We have the acceleration from the previous question here, negative 7.37. Now, we can be able to substitute into this formula. Remember, I've always said in Edexcel, Igcse exam, most of the time, this is the equation of motion they want to test and know whether you know how to use it. Don't go to that exam without knowing how to use this formula, please. And don't say I never told you. I've already told you in this letter. This letter is meant to remind you key areas to look at. Don't be... let me not be offended. Let me not be offended. Take whatever that is in this letter serious, because you will see such question. Stopping distance. Yes. And another interesting area we looked at when we were discussing, and we said, when you come to school using the bus, or you come to school by bus, there's some scenario whereby the driver observed an incident, maybe a child crossing the road. Then the driver was thinking quickly what to do. Then after deciding what to do, the driver moved his foot from the accelerator to the brakes, and he applied the brakes for the bus to stop to avoid knocking the child. Now, stopping distance includes thinking distance and braking distance. And what is this thinking distance that we are talking about? Thinking distance is the distance covered by the vehicle while the driver is thinking exactly what to do. That moment when the driver is trying to analyze the situation, the car is still moving. Then now, the distance moved during that time of thinking, during the reaction time, is what we call thinking distance. And there are different factors that can affect the thinking distance. Number one is the poor visibility. If the driver is driving on a road and maybe it's there is smog, yeah, it's raining, then it means that the driver cannot be able to see clearly. So it will take a longer time to decide what to do. And now that means the car or the bus or the vehicle will cover a longer distance. Thinking distance will be longer. If the driver is under influence of drugs, yeah, if the driver has used alcohol, and we usually say don't use alcohol and drive, because this is going to affect the thinking distance and this may cause an accident. Another factor that can affect is the speed of the car. Another one is tiredness and the fatigue. If the driver is tired, the thinking distance is going to be longer, or depending how it will be affected. Braking distance. Now remember, after the driver has analyzed the situation and has decided exactly what to do, and he has seen need for him to apply the brakes, he will move now the foot from the accelerator and then step on the pedal, the brake pedal, so that the car can now slowly slow down and come to a complete stop. So which means braking distance is the distance moved from when the brakes are applied to when the vehicle comes to a complete stop. Remember, the vehicle does not come to a complete stop immediately when the brakes have been applied. It will accelerate as it's moving forward. So there are different factors that can be able to affect this braking distance, which include condition of the brake. If the brakes are sharp, it means the vehicle will come to a complete stop and the braking distance will be short. The condition of the tires. If they are worn out, it means there will be no sufficient friction, and it means that this vehicle will take a longer distance in order to stop. Condition of the road. If the road is slippery, if it was raining, if it was icy, it means that the car can even slide, and it will cover a longer braking distance. And I said, this information of thinking and braking distance can be represented on a graph, velocity time graph. This region where the graph is flat like this, it means this is the thinking distance. This is the time during when the the driver was exactly thinking what to do. And now, if you are asked to work out the thinking distance, you'll work out the area under this region where we have a square. And braking distance now, you see, initially, the vehicle was moving at a particular speed. Then when the brakes are applied, the speed will decrease until it comes to a complete stop. So this triangle represents the braking distance. So if you can work out the area of the triangle, it means that's the braking distance. And if you can work out the gradient of this line, it means that is the deceleration of the car. If you are asked the initial speed, you read this region. If you are asked the reaction time, you read this particular part. Please, if you have found value in this particular letter that I've written, consider giving this video a thumbs up, and also you can be able to subscribe so that when I'll be able to write the second letter now, you'll be also be notified, and you'll be able to get benefit. You can be able to learn. Now we are told describe factors that will increase the braking distance. Factors that will increase braking distance. Whenever you are given question, try to check whether they are, make sure you are answering the question that they're asking you. You know the factors, but coin your answer, modify your answer so that it can be able to fit that particular question. Two factors that will increase braking distance will be if the tires are worn out, hence there will be less friction. Poor condition of the brakes will also increase braking distance. When a van is fully loaded, the mass increases to 2,500 kg. And then we are supposed to calculate the time taken to bring the fully loaded van to rest when it's traveling at initial speed of 18 meters per second. So in this particular question, you are first supposed to work out the acceleration. What is the acceleration at this particular point? So you can be able to use the formula F equals to ma, and remember the resultant force there was 14,000, and then if you work it out, you are going to get 5.6 meters per second. But remember, initial velocity was 18 meters per second, final velocity, it came to rest, so the final velocity is 0 meters per second. And we can be able now to substitute in order to get the time into the formula, which is going to be 3.2 seconds. Another particular question you can see here, this was also an exam question that had been asked before. So you are told to calculate the acceleration between 1.8 and 8.0. 1.8 is at this point and 8.0 at this point. So to work out the acceleration, initial velocity was 30 meters per second. Final, it came to rest 0. So it will be 0 minus 30 over 6.1. We are getting 6.1 because we have subtracted 8.0 minus 1.8. So I think I need to change this. I need to change this because this is 1.8, which we are going to subtract from 8. 8 minus 1.8. That was this is going to be 6.2. So we need to change this. 6.2 at this point. Yeah. Now when we have 6.2 here, also this we are going to change it. It will be 30, negative 30 divided by 6.2, and the answer here is going to be 4.83. 4.838. So this is going to be 4.84. 4.84 as the acceleration at that point. I need also to change this to 2. That was an error. So meaning that if we work out this will be 0.5 times the height the height is 30. We are working out the braking distance. Braking distance is the area under this particular region. Area in this region. And area under this region is going to be area of a triangle, which is a half base times height. Our base is 6.2 and our height is 30. So if we work out that 6.2 times 30 times a half is going to be 9.3. 9.3 is the if you work out this, it's going to be 93 meters. So 93 is the distance covered during when this car was braking. Now next we need to move to weight. We said weight is calculated by the formula mass times gravity, and weight is a vector quantity because it has got both size and direction. Weight varies from place to place because it depends on the gravitational field strength of a planet. So if you are given a question to do with weight, this is the formula you are going to use. Remember, weight is a vector quantity while mass is a scalar quantity. Let's talk about air resistance. Air resistance is a force that opposes motion of objects when they are moving through air. Now, for instance, if it's raining and you get your umbrella, you open it and start running, you will feel there's a force pulling you back, and that is air resistance. When objects are moving through air, we have different forces acting on them. We have weight, and also we have drag or air resistance. So if weight equals to air resistance when objects are moving through, it means the object will be moving at a terminal velocity, and whereby we said in class that terminal velocity is a constant velocity attained when weight is equal to the air resistance. So when the two forces are balanced, then the object will be moving at a constant velocity, which we call terminal velocity. Something that you need to remember is that as the speed of object continue increasing, as the object moves down, as the speed is increasing, air resistance also increases. So it will reach a point where air resistance will increase and it will be equal to the weight of the object. When that is the case, then the object will now stop accelerating. It will be moving at a constant terminal velocity. And this now concept is really helpful when a parachutist is jumping out of a plane. Before a parachute, a parachute enables a parachutist to land at a lower speed so that this person cannot be injured. So when the parachutist jumps out, the weight will be acting down and there will be a very little air resistance. So the parachutist will accelerate at a very high rate. As the parachutist accelerates, air resistance also increases, because when the parachutist jumps out of the plane, weight will be pointing downward, but air resistance will be pointing upward. At the point of jumping out, weight will be more than air resistance, so the resultant force will be acting downward. So in the region OB, this region OA, this is not OB, let's identify this region OA. In the region OA, the parachutist is accelerating and unbalanced forces are acting downward. You will be meeting questions in your exams and you are asked, what's happening in the region OA? You are going to say weight is pointing down and weight is more than air resistance. So the unbalanced forces are acting downwards, which means the parachutist is accelerating. At AB, drag increases, so the parachutist decelerates. So you can see now the slope is decreasing at this point, meaning air resistance now is increasing, and the person now starts to decelerate. At BC, this is a point when the drag and the weight are equal. So the parachutist will be moving at a constant velocity, which we call terminal velocity. In point C, the parachutist will open the parachute, meaning there will be a very large surface area that will be acting there. So air resistance will increase. So the unbalanced forces will be acting upward. Then the parachutist will start decelerating. When the parachute decelerates, when now air resistance is equal to the weight again, now the person will attain a second terminal velocity. So which means this first terminal velocity is when before opening the parachute. This other terminal velocity is when now the parachute has been opened. Now you can see this will be, let's say maybe this is 5. This is 5, and maybe this is 80 meters per second. So which means that 80, let me use 80 meters per second. So which means the parachutist will land at a very low speed, meaning this person is not going to be injured. So basically that's what we discussed regarding parachutes. In this region, the person is accelerating, then here decelerating. At this particular point, unbalanced forces are acting upwards, but OA, unbalanced forces are acting downwards. You remember momentum? When I came to class and said it's easier to stop a ball that is moving slowly than a ball that is moving very fast. A ball that is rolling slowly, it has less momentum compared to a ball that is moving very fast. So momentum is a product of mass and of an object and its velocity. So if you take mass and you multiply the velocity at which that object is moving, you'll get momentum. Momentum is a vector quantity because it's obtained from velocity, and momentum has got direction. Also, we discussed about the principle of conservation of momentum, whereby we said that sum of momentum before collision equal to the sum of momentum after collision. Remember this example that I gave you in class, whereby I said a car of mass 4,500 kg moves at a velocity of 8 meters per second. Calculate the momentum. Momentum equals to mass times velocity. Mass is 4,500 kgs. Speed is 8 meters per second. If you multiply this, 4,500 times 8, you get we need to change this. For this is going to be 36. This is 36,000 kilogram meter per second. This is 36,000 kilogram meter per second. And the second example that we have here is a ball of mass 8 kg moving at a speed of 15 meters per second collides with a stationary ball of 10 kg. If after collision they combine and move together at a common velocity v, using the principle of conservation of momentum, calculate the common velocity after collision. Remember, we're going to use the concept momentum before collision equals to momentum after collision, and this is going to be the first object, the first ball was 8 kg, but its speed was 15 meters per second. So it will be 8 times 15, which is going to give us 120. Now, the second ball, because before they collide, the second ball was stationary, meaning its velocity was 0. So 10 times 0 will be 0. So momentum before collision will be 20 plus 0. Now, momentum after collision will be, because they combined and moved together. So we are going to get they're going to move together as one body. So their mass will be combined. So it will be 8 plus 10. So that will be 18. But remember that its velocity after collision is going to be v. So it will be 18 times v, which is going to be 18v. Now, using the principle of momentum, momentum before equals to momentum after. 120 equals to 18v divided by 18 divided by 18, which is going to give us 6.67 meter per second. This is one of a question that you can be given. Another type of question you can be given is like this one. You are told write the equation connecting mass, momentum, and velocity. This is the formula you are supposed to write. The second part is a car of mass, a car A of mass 800 kg moving at 12 meter per second collides with another car B of mass 500 kg moving at 4 meter per second. So you can see these two cars are in motion. One is moving at 12 meter per second, another one is moving at 4 meter per second. After collision, car A continued to move in the same direction at 10 meter per second. Calculate the velocity of car B. Now we're going to use the same concept, which is momentum before equals to momentum after. So we are going to say mass of A times the initial velocity of A. Initial velocity of A was 12 meters. Mass of B times initial velocity of B. Initial velocity of B was 4 meters. So momentum before collision will be 800 times 12 plus 500 times 4, which is going to translate to 800 times 12. I keep on checking this so that we don't have some errors there. We have 9600 and 500 times 4 is going to give us 2000. So if you add these two, you are going to get total momentum before collision is 11,600. Now, momentum after collision will be mass of A times the final velocity of A. Final velocity of A, we were told after they collided, A moved at 10 meter per second. So it will be 800 times 10, which is going to be 8,000. And we were told after we are supposed to find the velocity of B after they collided. Now we can say let the velocity of B be V. So it will be 500 after collision times V. And now if you work it out, we are going to have this as what? 11,600 equals to 8,000 plus 500 V. If we substitute and rearrange rather this, we are going to get the velocity VB. This is the velocity of the car which we called B, is going to be 7.2. Momentum before collision equals to momentum after collision. Further, we talked about the relationship between change in momentum, force, and time. Now, we say force equals to change in momentum over time. Now, change in momentum is actually final momentum minus initial momentum. So, if we can be able to factor out M, we're going to remain with V minus U over T. But remember, V minus U over T is very relational. We have done this in acceleration, in motion. So this part represents acceleration. So this where we got F equals to MA for force equals to mass times acceleration. Because if you replace V minus U over T with A, it becomes F equals to MA. The second letter will involve. How do we use this formula? And what are the other areas we're going to be tested?